Your Snowflake bill keeps growing every month. You can see what you spent, but you can't easily tell why costs suddenly jumped, which team is driving those costs, or which queries are suddenly taking way longer to run. Sound familiar? Here's the thing, Snowflake gives you incredible data infrastructure, but when it comes to understanding your cost, you're pretty much on your own. That's where AI changes everything. In the next 10 minutes, I'm going to show you the top 5 cost-saving opportunities that you can only identify with AI. The kinds of insights that would normally take hours of SQL queries and manual analysis. These aren't theoretical. These are the real patterns we've seen help customers cut 32% off their Snowflake bills. In Snowflake's UI, you can see your total spend, you can see warehouse level costs, you can even drill into queries. But here's what you can't easily do. You can't identify which workloads had unexpected cost spikes. You can't see which queries are failing most often and wasting your money. You can't compare run-to-run performance to understand what changed. To answer those questions, you need to write complex SQL queries across system tables, join account usage views, build custom dashboards, manually investigate every spike, along with some other things probably. For most teams, this means hours of work every week, or worse, you probably just don't do it, and costs keep climbing. But there's a better way. This is Altimate Studio, an AI-powered analyst for your data stack. It works with Snowflake, Databricks, dbt, and other tools in your data platform. Instead of writing SQL, you just ask questions in plain English. And to make it even easier, we've built in the most common questions that uncover the biggest savings opportunities. These 5 prompts right here, these are the questions that consistently identify where money is being wasted. Let me show you how they work. Opportunity 1 is to catch unexpected cost spikes before they compound. This is usually where the biggest waste is hiding. A workload that normally costs a certain amount suddenly spikes, and nobody notices it for weeks or months or sometimes even years, unfortunately. So we thankfully have a prompt ready for you inside of Altimate Studio, and you can see here it's which workloads had unexpected cost spikes this week compared to the normal patterns. And to run that, we can just click the use prompt button here. It's going to take us in here, take us back to the UI where we can just click send message, and it's going to run that for us. And so as this thing's going to take a couple minutes to run, and then once it's done, the AI is going to give us a nice view of what it found compared to a baseline of the past month. So let's jump into the results and see what it found for us. And so it's finished running. And what I really love about Ultimate Studio, which again, I'm a little biased, I might work here, but what I love about this is that not only does the AI do this work for you, but it also tells you what it's doing. We're not a black box. We want to let you know what's going on in every single step. And so I'm not going to read through this whole screen, but this is telling us exactly what's happening as the AI is building this report out. And at the very end, it says, hey, now I have all the data that I need. Let me compile the final report. And jumping down, now we have our final report here. And so we have our executive summary that breaks down here. So it tells us our analysis period, which is February 12th through 18th, which is this week, versus this 4-week baseline between January 15th and February 11th. Our total weekly spend, which is around $2,200. Our anomalous warehouse identify, which is 5 of them have some cost deviations above baseline. And our primary finding is that there's a gradual cost creep across monitoring and compute workloads. Okay, so then we're going to dive into kind of looking at what's happened here, and then we're going to have some suggestions at the end of how you can fix it. So we have a bunch of different views here of how we can look at this. So starting off with kind of a bar chart here of cost deviations this week. So this is just a percentage above expected. So it doesn't always tell the full story. We're going to have a table below this, but you can see that this Streamlit notebook warehouse is 254% more than the normal baseline percentage. That's a big jump. And then we have some other warehouses that are up as well, but that's a massive jump. So let's go look and see what that dollar amount looks like. So below that, we have a table that shows us exactly what we have here. And so in this table, you can see kind of the actual dollar amounts along with that percent change. And so that Streamlit notebook, you can see that it went from 17 cents to 61 cents. So that's a 254% change. It's massive, but with that actual dollar amount, not that big of a deal, right? So it is a critical thing to start taking a look at, because if we're using Streamlit notebooks a lot more in our workflows, we definitely need to keep an eye on as that grows. But if that's just something that someone was playing around with at the business that week, not that big of a deal to worry about, right? So then jumping down to the next one, this monitoring warehouse, it goes from 154 to 134, which is a 15% change. That's something that we might want to look at, right? Like that's something that we should probably take a peek at, which we will in just a second. So continuing down, you can see that we have a line chart here that shows us those top 3 warehouses to take a look at. And then as we come down here now, it's where we get into like the real kind of meat and potatoes of this analysis. So we have detailed root cause findings. So We have this monitoring warehouse, which has a steady upward drift. It tells us that amount with a z-score. The pattern says that it just persists in upward trends, representing a 27% gradual increase over 5 weeks. And the root cause is a higher per query cost across all Airflow monitoring users. So it gives us all that information there below. And then it has a top contributor as well. So it's telling us who the top contributor is to this finding, which is this production Gov Airflow user, which tells us it's $71 this week, which is 46% of that warehouse cost. And then it gives us a likely cause of like growing table sizes and monitor data sets are causing scans to expand organically. So again, like there's probably nothing super wrong there, but there's just something we could potentially clean up, which we're going to give you some recommendations. We have a cost attribution summary here that shows us, hey, like here's its expected total, and then here's the added on for what got to the actual total for why it's 2180 versus 2028, right? So a little bit of an increase there, and it's giving it per warehouse that you know kind of how you should cost center those things. So jumping down here, now we have our recommendations. And so we have immediate actions, long-term strategy, and short-term improvements. So immediate actions, so the biggest one there was that Streamlit notebook, which was just like, hey, it's a low dollar impact. No actions needed, but monitor if the sessions become more frequent. Again, there's just something for you to keep an eye on. Nothing to worry about completely right now. We have that top warehouse, which is like, hey, like these are 920 canceled Sigma queries. Consider setting query timeouts or working with a Sigma user to optimize those queries, right? So there's some steps there to make sure that doesn't get out of control. Short-term improvement on the monitoring warehouse is to review the monitoring queries run by that user. The top queries scan 2.5 gigabytes each and run 10 plus minutes. Consider adding incremental filters or materializing intermediate results. So that's a step that you can take to lower the cost of that monitoring warehouse. Same thing for the ingest as well. And then we have a long-term strategy there, which is kind of a cross warehouse, which is multiple warehouses show modest but consistent cost creep. This is likely driven by organic data growth, which, consider quarterly reviews of clustering keys and partition pruning. So just, hey, this business is growing their data. That's something that happens to every business, right? So no big deal there, but just definitely something that you should take a look at to make sure that, like, hey, these costs don't continue to grow and grow and grow. At some point, you're going to have to start doing some partitioning and things like that to control that cost, or else they're just going to keep growing with your business, which is not the goal for sure, right? And then last but not least, we have a quick summary here that kind of just shows off what we showed off in this first opportunity, in this first prompt. So that's all for opportunity number 1. Let's jump into opportunity number 2. Opportunity 2, stop paying for queries that produce nothing. Failed queries are pure waste. You're paying for compute that fails halfway through and delivers zero value for your business. Let's see what the AI finds. So the AI is done with its analysis, and let's take a look and see what it found. So you can see that we have 3.6 million total queries, 46,300 total failures, with an overall failure rate of 1.28%. That's not a ton, but still it's worth taking a look at, right? So you can see that we've wasted $46 on wasted cost on failures for like the past 7 days. So again, like I mean, you're not going to bankrupt your business with $46 a week, but you'd much rather not waste it, right? So let's take a look at our top 3 root causes. So our first root cause is object database does not exist or is not authorized. And you can see that is 67% of all failures. So, wasted cost-wise, not that bad, but we're getting a lot of errors because things aren't found or not authorized, right? So something to take a look at there, right? So that's around 67% of your failures are just based on that one error. The second root cause is this invalid identifier updated, which is a SQL compilation error, which is 18% of all your failures. Again, not a big cost on that one, but the big cost is this 604 error code, which is SQL execution canceled, which is 14% of your total failures, but $44.5 worth of change or worth of your errors, which is 99.9% of the cost on your failures this month, right? So that's a big issue. So we can get a detailed breakdown here, which for each one of these is going to give you kind of the key patterns and what's going on there. And let's see. Let's take a look at this missing objects unauthorized access, which is that 68% of failures. So you can see our key patterns here are repeatedly querying missing underscore wall tables with some examples, underscore silver tables. And there's 159 failures per object, which is running continuously since February 12th. We're querying databases that don't exist, there's some examples there. And then multiple Airflow users across all environments are hitting similar missing objects, which there's a lot of failures there as well, right? So this root cause is this ride-along log and silver labeled silver layer tables, appear to have been dropped or renamed, but Airflow DAGs and Sigma dashboards were not updated, right? So that's a big issue that you could definitely solve, but it's definitely picking it out for you. We have some more things for this invalid identifier and the SQL execution canceled, which that's our biggest that's our biggest cost center here, right? So it's telling us who did that. And then, of course, this affects 4 users across 3 warehouses, so it tells you where you can find those things, right? At this point now, we have our workloads with the highest failure rate, and then the different roles that are attached to them. And so for these, you can see that we have 100% failure rate down to 24% failure rate. So just good to know which workloads are giving you those failures. And then now at this point, we have our recommended actions. So for our recommended actions, we have fix Airflow DAGs for that user, investigate missing databases, address Sigma query cancellations, and then, of course, fix that specific workload because they have near 100% failure rate. So probably should fix something there, right? So that's opportunity 2, which is finding out what's going on with those failure rates in your queries. So let's jump into opportunity number 3. Opportunity number 3, catch performance degradation before cost spiral. Performance degradation is sneaky. A query that used to run quickly now takes much longer. Runtime increases means compute costs increase. Here's what our AI will find for you. So here's the analysis that the AI got for us. So we have our executive summary just telling us what happened here, right? So then we're just going to jump straight into workloads with significant runtime increases. So we have our 5 warehouses here that have last week averages, this week's averages with an average change, and then a cost impact here, right? So you can see this first warehouse went from an average of 5.8 seconds to 6.78, which is a 17% change and has a cost impact of a little bit there. And same thing going down to the other 4 warehouses as well, of just like what that cost impact is along with that change. So that's good information there for us. The next thing the AI talks to us about is actual user data here, right? So for our user data, you can see the user, the warehouse, and then their average change and how long the things took there, right? So if you have one specific user, for example, that their queries are taking a lot longer, it's going to tell the AI is going to tell you exactly who that is, so that you can help that person work with their queries a bit more. And I'm just very thankful this technology didn't exist back 5 or 6 years when I started my data career, because I promise you, Stephen.Johnson at where I was at the time would have been number 1 on the list, probably even number 2 and number 3. So yeah, good information here about users, just to let you know what's going on with your user base inside of your company as well. We have a daily runtime trends. So we have average query runtime across a week there. So you can see that first warehouse, the red line there, dropped down and then jumped right back up. So something went on there on February 15th that might be worth taking a look at. And then obviously it's went way back up afterwards, a bit above what it normally was. So something to just take a look at there. And then of course we have our detailed findings here as well. So for our detailed findings, so like finding number 1 is that this warehouse has a steady runtime escalation. And it just says like, hey, the select queries in this warehouse went from 6.61 seconds to 7.29, which is 10% increase. An increase in the median, and then of course like data scanned increased as well, which is probably going to explain what went on there. Has our pattern and our root cause signal there as well, which is this underlying table growth is driving the longer runtimes. And again, we have findings across all these warehouses. I'm not going to go through all of this because I don't want to bore you. Just letting you know that those are there for each one of those warehouses there. And then we have our summary of significant slowdowns. So this first one is Sigma query, so sustained increase there. With a high severity of telling us like, hey, like it's 30% above the median, with a larger data scan per query, which tells us like, hey, we might need to partition more, or other things that you can do inside of your data to make those queries be a bit smaller and run quicker. And of course that goes from high to low severity there, which is like a one-time outlier there on that bottom outlier. So this is opportunity number 3. So let's jump into opportunity number 4. Now those first 3 opportunities, cost spikes, failed queries, and performance degradation, those are the big ones that apply to almost every Snowflake account. But there are also workflow-specific questions that help you track more granular things happening in your environment. For example, compare the most recent run to the previous runs. What changed and why did it cost more or less? This is perfect when you have a specific job that suddenly got expensive. The AI does a side-by-side comparison and tells you exactly what changed, whether it's data volume, query execution plans, or warehouse behavior. Which tasks are the bottleneck in this workload, and what's causing them to be slow? When you have a complex data pipeline, this pinpoints exactly which step is slowing everything down, so you're not optimizing the whole pipeline, just the actual bottleneck. And lastly, how consistent is the workload's runtime? are the runs that took much longer than usual. This one's critical if you have SLAs. It identifies which runs are outliers and why so that you can fix the root cause of unpredictable performance. These workflow-specific questions give you surgical precision for optimizing individual jobs and pipelines. Now, let me show you how some of these optimizations can actually run on autopilot using our AI agent. Now, here's where this gets even better. Once you've identified these cost-saving opportunities, some of them can be automated. This is Autotune, our AI agent that continuously optimizes certain aspects of your Snowflake environment. You simply toggle Autotune on in the UI. From there, the AI continuously monitors your warehouses and makes cost-saving changes automatically where it is safe to do so. You have full control over what type of changes Autotune can make, such as warehouse scaling adjustments, automatic warehouse suspension when idle, warehouse size optimization, and even more. You can choose which optimizations to handle, and the AI handles the rest. And you can see exactly what changes Autotune has made. Full transparency into every optimization. So while you'll still need to manually address things like failed queries or data pipeline issues, the infrastructure level optimizations, those can run on autopilot. So let's recap the 5 cost-saving opportunities you can only identify with AI. Unexpected cost spikes, failed queries wasting compute, performance degradation, run-to-run cost variance, and unpredictable runtimes. These are the patterns that consistently add up to significant savings on your Snowflake bill. And the best part? Each of these would take hours to identify manually. With AI, you get answers in seconds. This is what modern data cost management should look like. Not dashboards you have to interpret, not alerts you have to investigate, just questions and answers that lead to action. Want to see how this works on your own Snowflake account? Contact us to get started. There's a link in the description. We'll show you exactly where your savings opportunities are and how you can work with us on the Ultimate platform. Thanks for watching, and we'll see you next time.